1. For division, we're going to use that fraction line. So we're going to have 2 to the 6th power over 2 to the 4th power. Now, without actually evaluating that, without actually doing 2 times 2 times 2 times 2 to get that 64, let's write out the meaning behind this. What does 2 to the 6th mean? Good, because what is our base? 2. What is the exponent? 6. Okay, on the bottom, what is 2 to the 4th? What's the base? 2. That tells us what we're multiplying. What does the exponent tell us? Yeah, how many times we're going to multiply. And on the bottom, how many times are we going to multiply that 2? 4. So that's just a quick review from yesterday if you weren't here or if you're still a little confused. This is struggling today. It's a little delayed. All right, so golly. On the top, when we rewrite this, in the numerator, in the top part of the division problem, how many 2's would we have? 6. That'd be 2 times 2 times 2, 6 times. And how many 2's are going to be in our numerator? I'm sorry, in our denominator? 4. But we know when we have a 2 over 2, what is 2 divided by 2? It's just 1. With 1, do I need to include the 1? No, when we're multiplying, do we need to always write times 1? No. So that would be a 1. What else would make a 1? Do we have another 2 we can divide? Yeah, another 2 divided by 2. That makes a 1. 2 divided by 2. That makes a 1. And 2 divided by 2. Yeah, these all make 1. So we're really left with 1 times 1 times 1 times 1 times 2 times 2. And we don't need that 1 times 1 times 1 times 1 because we really know 1 times 1 times 1 times 1 is just 1, right? How many 2's do we end up with? 2. So we get 2 squared, and 2 squared really means 2 times 2, which is 4. So let's apply that to a problem that involves not numbers. Ones that we would actually do with variables. Okay. So for problem 2, we're going to do x to the 3rd power over x to the 7th power. So how many x's are going to be in my numerator? 3. So I have x to the 3rd power, so x times x times x. And how many x's will be in our denominator? 7. I'm not going to count out loud because that's a lot to count. When we see that x in the numerator and the x in the denominator, it doesn't matter what that number is, right? Anytime I take a number and I divide by that exact same number, what is it going to equal? 1, right? 3 divided by 3? 1. 100 divided by 100? 1. 267 divided by negative 1,267? 1. We just made ones. 1 over x to the 3rd, or 1 over x to the 4th. and just get to our answer. Can you say that louder? Subtract. Yeah, 7 minus 3 is 4. So this is what we call our quotient of powers. Does anyone remember what does that word quotient mean? Yeah, it's a division answer or an answer to a division problem. So quotient of powers is the name of the property. We're going to use this when we see on top we have like an a to the x power. And then on the bottom we have another a and then maybe to like a y power. That's a really teeny tiny y. Sorry. Got small. What? Okay. So we have a variable on top and a variable on bottom, but they're the same base. So we have an a and an a. So what this tells us is when we divide, powers with the same base. What that tells us we're going to do is we are going to subtract our exponents. So we're going to do one more problem with this property, and then we'll move on. We have one other property we're learning today with division. What's up, Destiny? Can you wait until after notes? Okay, number 3. We have m to the 5th power, p to the 6th power, over m to the 3rd power, p to the 10th power. So in our answer, how many variables are we going to end up with? 2. We're going to have an m and we're going to have a p. So we're going to deal with those m's separately from those p's. If we wanted to, we could write it all out as m times m times m times m times m times p times p times p times p p times p over p times p times p times p times p, and we could see how many like once. Okay? You can just follow. How many m? 2. We're in the numerator. You didn't say that? Somebody said that. Why? How do you know? When we take it out, we're going to have 10 p's. So we're going to take away 6 p. P is going to be in the numerator. Yeah. The 10. If you want to show our thinking here, 2. So if you want to write that, you can go. That might be helpful later on. All right. We have one more. I'm going to divide up my... All right, this time for quotient, which sounds... We're going to start with a quotient over b. A squared over b, like I did before. Power. A squared over b. Apply across. So we apply all the denominators. E to the power of 3. Power of a quotient. And when I have them, this to this. Power. And get my final answer, a to the 6th. Yeah, we're just multiplying. Multiply it by the inside. So it's... Alright, so that is... And what's goofy about... Okay, and with a quotient. To the c power. This is with this one, and there's an x... Power of the numerator. And find the power of... Denominator really just means... It means to find the power, multiply our exponent. Of the denominator, if we brings us to our very last.
Hey, you know what pi is? Okay, actual number. Mrs. Pi was, and the Marriage Council. Well, Mr. Pi
keeps going on and on and on. All right, in parentheses here, x power. I'll give you about 40. Just wait till we're done. All right. Exponent of just the, and we'll do that 5 times 2. Exponent of this 5, 1. And that exponent secretly. You actually want to find 5 to the third. Remember, we can use this. Okay, so we would do leggy. So with fraction, check to make sure. 1,125. Y to 1,125. On your practice, to type in